Cumulative probability. Consider the probability distribution below. Sometimes we want to know a range of probabilities, such as the probability that x is less than or equal to 2. Clearly, we can add the probabilities for 0, 1 and 2 to do this, but if there are a large number of values of x and we want an extensive range, such as from 10 to 16, this can be a tedious calculation. However, use of cumulative probabilities can reduce the time taken to do these calculations. So the cumulative probability is the probability of x being less than or equal to x. So the first one is 0.2. But the next one, less than or equal to 1, is 0.4 add 0.2. So this one is 0.6. The next one then is 0.8 because it's 0.2 plus 0.4 plus 0.2, or the easiest way to calculate it is the 0.6 add the 0.2. So the next one is 0.8 add 0.1, which is 0.9. And cumulative probabilities should, of course, always finish at 1. If we want to know the probability that x is less than or equal to 3, then we can immediately read this off as 0.9. If we want the probability that x is between 1 and 3, note inclusive, we can do the calculation. The probability x is less than or equal to 3, take away the probability x is less than or equal to 0, which in this case is just the probability that x equals 0. So we'll then get the values for 3, 2 and 1. So that's going to be 0.9, take away 0.2, which is 0.7. And we can see that's true because it's these three probabilities that we've added together.